everybody, this is Mrs. Ellsworth, and what we're going to be talking about again is on lesson 4-3, but this time it's going to be about, this is going to be part 2. We are just going to be talking strictly about division, okay, dividing monomials. Do you remember that monomials is any type of number or variable or a combination of the two where you don't have an addition or subtraction sign? Okay. So, do you remember that we also talked about multiplying monomials? So, like, you would just go and add the exponents. Okay. And then now we're going to be talking about dividing monomials. Okay, and so look at this. So we will go and expand this out to 4 times 4 times 4 times 4 times 4. Okay, and then on the bottom we've got 4 squared, so it's 4 times 4. And then what they showed is that go ahead and cancel out a couple of those. Okay, go cancel out that. So how many do I have left here? I have 4 to the 3rd power on top, and then I have just 1 left on the bottom. So we're good. So what really happened here? What happened so that we actually went from this to that? We subtracted those two exponents. So when you multiply, you add the exponents, and when you divide, you're going to subtract your exponents. So here's another way of looking at it. And they've got a to a power m, we'll call it, divided by a to the n power. What do? They go and they subtract it. Okay, so they go subtract it. So in this case right here, you've got 3 to the 6th power divided by 3 to the 3 squared. And so now we're going to take 6 minus 2. And we'll get 3 to the 4th power. Let's practice some of these. Okay, so in example 4, find the quotient. Quotient means divide it. So we're going to actually have 8, same exact base. And then we'll have, I'm going to do my teacher talk here, 5 minus 3. So you'll actually have 8 squared. Okay, and that's it. A lot like the last one, except for multiplying you add and division you divide. Okay, on this right here, we've got this equals the same base, and we're going to go ahead and subtract those, so 7 minus 2, and so that's going to equal c to the 5th power. Okay, now let's look at this one. This one is got the same exact base, but it's going to be negative 2, so always the top one minus the bottom one, minus 2. Do you remember this is plus a negative? So it's really going to be 2 to the negative 4, because when you take a negative, add another negative to it, you're going to get a bigger negative. Now notice that this does not tell us whether or not this has to have a positive exponent, but in our homework it does tell you to have a positive exponent. So you're going to have to put this downstairs, and then remember to change that sign of that exponent. Okay, it's not so bad. Okay, and then last but not least, we've got d, the same exact base, right? And then it's going to be 5 minus a negative 2. Okay, remember you add the opposite. So it's really d to the 7th power. That's good. Okay, what I want you to do is I want you to try all 4 of these here on the bottom, and then pause it and see what your results are. Okay, so pause it. Okay, and this one right here is pretty nice. It's going to be 3 to the 9 minus 2 power, so that's going to equal 3 to the 7th power. Okay, and then I want you to do this one for our 2q, and this one. And we'll see those results tomorrow, and I'll have that real quick little thing you do right at the beginning, start a class, right? As you're getting on Zoom, get onto that and go ahead and put in your answers for that. Okay, and then let's do one more together before we do example 5. And that is going to be the same exact base. It's going to be s, and it's a negative 4 minus 1. Okay, so that's really plus a negative, isn't it? So s to the negative 5 power. And so we're going to want to go 1 over s to the 5th. Okay. So I can see that if you were struggling with yesterday, that you need to come and see me, or else ask to see me during lunch tomorrow to make sure you get this down, because that negative exponent has to be, you have to know how to do that, don't you? Okay. So let's look at example number 5. Okay, the table shows approximate diameters of Earth, Mars, and Neptune. So you see that they've got them written in exponential values. How nice. They've got the same base on them. How nice. Anyway, about how many times as great is Neptune's diameter than Earth's? So we'll take this one, divide by that one. But it's usually the biggest divide by the smallest anyway, and it seems like it's in the same exact order as that. So they want you to write a division expression, and it's going to be 2 to the 15th power divided by the 13th power. How did I know I was going to do division? Because you see the word times here. Well, let's think about that for a second. Let's say that one student had 4 pieces of fruit, and that you had 2 pieces of fruit, and you wanted to say how many times larger their amount of fruit is than yours. How would you do it? You would go and divide it. So once you divide that, you see that they got 2 times as many fruit as you do. Okay, so division helps show how many times larger that it is. And usually it's the bigger divided by the smaller. They may sometimes, it's also the first one mentioned divided by the next one mentioned. That's quite often how that you have to do that. But it says how many times is great. It's definitely the largest one on top of the smallest one. Sometimes they'll ask how many times smaller is that, and then it would be the opposite. Okay, so let's keep on going with this one. So we're going to subtract those exponents, so we'll get 2 to the 2nd power. Okay, and it says or 4. What's that tell you? That tells you that's 4 times the diameter of Earth. Okay, so, we're just now to the assignment, so it's a really short video. I will see you tomorrow, and don't forget you need to have those values for the 2Q for tomorrow at the beginning of class. See you later. Bye-bye.